Okay, so we're starting with synthetic division. So number 8, we have x cubed plus 7x squared plus 13x plus 6 divided by x plus 2. So synthetic division, we take whatever this x plus or minus whatever, we change the sign of it, so it's going to be minus 2, put it in a box. And then we copy down the numbers in front of the x's. They have to be in order, and if a term is missing, we have to put in a 0. So in this case, there's no terms missing. They're already in order. So 1, 7, 13, 6. So another thing to note, this initially is an x cubed term. When it comes down here, it will be an x squared term when we go to write our final answer. So we bring down the 1. We do 1 times negative 2 is negative 2, and we write that under the 7. 7 minus 2 is 5. 5 times negative 2 is negative 10, so we write that under the 13. 13 minus 10 is 3. 3 times negative 2 is negative 6. 6 minus 6 is 0. So in this case, there's not a remainder. So our answer, this is, like I said, now an x squared term, is x squared plus 5x plus 3. If there had been a remainder, we would have written plus whatever the number was over x plus 2. Is this familiar? Do y'all remember doing this at some point?
Is there other stuff in the section?
Yeah, a little bit, but I just was like, how thorough do I need to be with these examples? If y'all remember it, then not as thorough.
I didn't think I was going to remember it, but as soon as I saw you, like, put the 2 in the corner, I was like, oh, okay, I remember how to do this.
All right, 14. We've got x to the 6th minus 3x to the 4th plus 2x cubed minus 6x squared minus 5x plus 3 divided by x plus 2. And just something to remember is that if there's a number in front of x, or if x is raised to a higher power, we can't do synthetic division. We would have to do polynomial long division. Now this section doesn't have that, but that would be what we would have to do. Technically they do show polynomial long division, but I just do synthetic. So negative 2 is going in the corner in the box. Now notice x to the 5th is missing, so I need to put in a 0 for that, but I start with x to the 6th, so that's 1, 0, negative 3, 2, negative 6, negative 5, 3. So this one is just longer. So bring down the 1. 1 times negative 2 is negative 2. 0 minus 2 is negative 2. Negative 2 times negative 2 is positive 4. Negative 3 plus 4 is 1. 1 times negative 2 is negative 2. 2 minus 2 is 0. 0 times negative 2 is 0. Negative 6 times negative 2 is positive 12. 12 minus 5 is 7. 7 times negative 2 is negative 14. Plus 3 is negative 11. So my remainder is negative 11. So this was an x to the 6th term. So when I rewrite it, this is now an x to the 5th term. So I've got x to the 5th minus 2x to the 4th plus x cubed. There's no x squared term because it's 0. Minus 6x plus 7 minus 11 over x plus 2. And that accounts for the remainder part. So the next one say to use synthetic division to divide f of x by x minus k for the given value of k. So instead of them saying it's divided by this, they're saying k is equal to whatever the value is. So in terms of what we've had previously, k is the number that's being put into the box. So k already has the sign as it's supposed to be. And then it wants you to write your answer in the form of x minus k times whatever you had left here, and then plus or minus, as the case is, the remainder. I'm also okay with you just writing it like this. You don't have to write it in the other form. So I will, just because it says to do that, but if you were to leave it or forget how to write it in that form, I wouldn't tick off for that. So 26, we have f of x equals 2x cubed plus 3x squared minus 16x plus 10, and k is equal to -4. So -4 is going in our box because that's already been basically solved for us. And then we just copy down the numbers. Nothing's missing. So 2, 3, -16, and 10. So bring down the 2. Times -4 is -8. Plus 3 is -5. Times -4 is 20. Minus 16 is 4. Times -4 is -16. Plus 10 is -6. So I have a remainder of -6. So it wants the answer in, technically, f of x equals x minus k times q of x plus r. So when we go to put k in here, we have to change the sign of it. Okay, so this, because it was negative, when it goes in here, it's going to be positive. Okay, so when it gets plugged back in, we have then that our answer would be x plus 4 times, this was an x cubed term, so now it's x squared, so 2x squared minus 5x plus 4, and then plus the remainder was -6 over x plus 4. (32) f of x equals -5x to the 4th plus x cubed plus 2x squared plus 3x plus 1, and k is equal to 1. So we put 1 in the box. Then no terms are missing, so I just copy them down. -5, 1, 2, 3, 1. Bring down the -5. Times 1 is -5. Plus 1 is -4. Times 1 is -4. Plus 2 is -2. Times 1 is -2. Plus 3 is 1. Times 1 is 1. And then 1 plus 1 is 2. So I have a remainder of 2. So remember, when we write it, we have to change the sign of k when we plug it into the x minus k form. So we would have x minus 1 times, this was an x to the 4th term, so it's now an x cubed term. So minus 5x cubed minus 4x squared minus 2x plus 1, and then plus 2 over x minus 1. Any questions about those so far? All right, so next we're doing the remainder theorem. So just as a refresher, the remainder theorem says that if f of x is divided by x minus k, then the remainder is equal to f of k. So we're going to plug in k for x and f of x, and then whatever that number is the remainder. So $34 f of x equals x squared minus 4x minus 5, and k equals 5. So we're doing f of k, which is equal to f of 5, equals, and we just plug in 5 everywhere for x. 5 squared minus 4 times 5 minus 5. So 25 minus 4 times 5 is 20. Minus 5, so it's 25 minus 25, so that's just 0. So in this case, there's a remainder of 0. See if there's one that's not. 38 f of x equals 2x cubed minus 3x squared minus 5x plus 4, and k equals 2. So we plug in 2, so f of 2 equals 2 times 2 cubed minus 3 times 2 squared minus 5 times 2 plus 4. So 2 cubed is 8 times 2 would be 16. Minus 2 squared is 4 times 3 is 12. And then minus 5 times 2 is 10 plus 4. So 16 minus 12 would be 4. Minus 10 would be negative 6. Plus 4 would be negative 2, I think. Is that right? Yeah. So that one has a remainder of negative 2. Any questions about the remainder theorem?
It was a lot easier than it sounded.
It's so funny because I teach it in like 3 different classes now. I teach it in Algebra 2, I teach it in Pre-Cal, and then now in College Algebra. And it's like every book teaches it differently.
Really?
Yeah. Like in terms of how they set it up. Not like the theorems obviously hold true, but the way that they like set them up and stuff. It's very different in the College Algebra book versus the Pre-Cal book, which is funny because they're made by the same author.
That's weird. I feel like this was really easy.
The last thing in this section says to use synthetic division to decide whether the given number k is a 0 of the polynomial function. So if you get a remainder of 0 when we do synthetic division, it is a 0. If not, then it's not. So it says, the rest of the instruction says if it's not, find the, or give the value for f of k. So basically find what the remainder is. So that's all you have to do. So just combining everything essentially. So number 50, f of x equals x cubed plus 2x squared minus x plus 6. And they say that k is equal to negative 3. So again, because it gives us the k value, we put that in the box. No terms are missing, so I just copy down the numbers. 1, 2, negative 1, and 6. Bring down the 1, times negative 3 is negative 3. Plus 2 is negative 1, times negative 3 is 3. Minus 1 is 2, times negative 3 is negative 6. Plus 6 is 0. So this one is a factor. So I just want you to note that it is a factor after you've shown it if it's not.
So it's only a factor if it's coming out to 0.
If it comes out to 0. I'm going to pick one more and see. Well, hopefully it'll come out to not be 0, but if it does, then oh well. 52 f of x equals 2x cubed plus 9x squared minus 16x plus 12, and k is equal to 1. So 1 in the box. No terms are missing. So 2, 9, negative 16, and 12.
There's a remainder.
Oh, good. I'm glad. All right, so bring down the 2 times 1 is 2, plus 9 is 11, times 1 is 11, minus 16 is negative 5, times 1 is negative 5, so then 7, so not a factor. Remainder is 7. So that's how I would want you to say your answer. So if it comes out to 0, then you say it's a factor. If it doesn't, say not a factor, and then what the remainder is equal to. Any questions?
So are we still gonna have that? Are we gonna do try to do 3.3 tomorrow and have the quiz on Friday still, or are you just?
No, I'm just gonna do a take-home quiz
right.
for next week. Is what I'm gonna do. I'm gonna try to give it to you on Friday, but I may have to wait and give it to you, on Google Classroom.
Are you gonna just be due when we get back, or is there gonna be a certain time it's due?
I'll probably say Tuesday at midnight, and then that way you don't have to worry about it on the actual break part. So.
'Cause I wouldn't do it.
But as soon as I have it done, I mean, it'll be posted before I leave on Friday if it's not given to you. I'll probably try to find you and give you a copy if I don't even have it ready by class, but let's see. Seven, 13, 27, 35, 30, or wait, not 30, 43, and 49 and 51.